All right, today we're going to do some more examples on the triangle addition or the triangle sum properties that we talked about in the last video. So we're going to get started on page 53. So if you want to join me in your notebook on page 53. Okay, here on page 53, we're going to title it Triangle Sum Properties. Okay, and we had two of them. Okay, if we look at the valid list of reasons, I think they're on the back. We had the triangle sum theory, and then we had the exterior angle theorem. So triangle sum theorem was interior angles sum to 180. Okay, and I have a little example of that. So I just cut out a random triangle here, and we're going to label the angles 1, 2, and 3. Now, if these three angles were to add up to 180 degrees, that means that they would form a straight line. So over here on page 53, I'm going to kind of look at that. So I'm just going to draw a straight line here. Okay, so there's my straight line. So somehow when I take these angles together at once, they should fit on this straight line. So what I'm going to do is I'm going to rip these angles off. So there's angle 2, and there's angle 1, and angle 3. Okay, and these points here are the angles. So if I take these and kind of add them together, so there's 3, and if I add 1 to it, I'm going to line it up next to it. Then I take angle 2 right there, we can see that they fall on this straight line. So if I take angle 1 plus 2 plus 3, they equal 180 degrees. So this would be a proof by construction on that one. And then the other one was the exterior angle, what was exterior angle theorem. Okay, and that is an exterior angle is the sum of the two opposite interior angles. Okay, so let's say I'm gonna cut another triangle out here. Okay, and we're gonna look on page, I'm gonna do it on page 52 again. So the first thing I'm gonna do is trace the sides of this triangle. Okay, so then I want, if I get a straight edge, I want to extend all of those lines as best as I can. Okay, there's that one. There's that one. And there's this one. Okay, so these right here are the interior angles, sort of the ones that look acute. Okay, and the ones that look obtuse are my exterior angles. So I'm going to take this. This was like that. So I'm going to label it 1, 2, 3. 1, 2, 3. Now the exterior angles would be like this one. I'll put an X right there. That's an exterior angle. So what this theorem says is that this angle would equal the opposite two interior angles. So if I take this triangle and if I cut the opposite angles off, okay, I'm left with that angle. And then if I take, so I want to know this one, if I take this angle here and line it up with here, they equal. Okay? This all has to deal with that these two angles are a linear pair. Okay, they're a linear pair, but when I take these two angles and line it up over here, I get a straight line. Okay, so it goes back to this right here. Okay, it goes back to this fact. So this one stayed the same, and I took the opposite two angles and added them here, and that's what it equals. Okay, so we're going to do some examples of just finding some x values for those. So we're going to draw a line here, split our page in half, and I've got 6 examples. And do a very good job of that, but we got 6 examples that we're going to do here. Okay. And we'll start off fairly easy. We're going to use both theorems because the theorems kind of go together. So if I have this triangle here, we've got, this is 70 degrees, this is 60 degrees, and this angle here is 8x plus 2. Okay, so those are all interior angles. If I take the interior angles, they should sum to 180. So 70 plus 60 plus 8x plus 2 should equal 180. Okay, so we can combine like terms. So 70 and 60 is 130 plus 2 is 8x plus 132 equals 180. Subtract 132. You get 8x equals 180 minus 132. I don't have that memorized here. So 180 minus 132 is 48. Divide by 8. And x equals 6. Okay, so this value is 6, and then I could plug that in and find the x value if I wanted. All right, the next one. Again, we don't go off the drawing of the picture. In this picture, the drawing looks like all the angles are the same, but they're not. This angle is 70 and this angle is 50. And I need to find this exterior angle. Well, the exterior angle is the sum of these two angles. Okay, so x in this case equals 70 plus 50. So x equals 120. Okay, and that's actually 120 degrees because there's nothing else with x. Okay. Again, if I rip these two off, they will land right here. They'll line up on that angle. So you got 45 degrees and 140 degrees, and this is x. Okay, again, your exterior angle equals the sum of these two angles. So x plus 45 equals 140. So if you subtract the 45, x equals 95 degrees. All right. If we look at, we got three more here. See, this is 40 degrees. This is 65 degrees. And we want x over here. Okay, so on this one, x is an interior angle. So if I transfer that into here, x is there, and 40 is also an interior angle. 40 is there. Okay, I just need to add those three up and set it equal to 180. So 65 plus 40 plus x equals 180. So 65 and 40 is 105 plus x equals 180. Subtract 105 and x equals 75 degrees. Okay, so even though it doesn't really look like an interior angle right away, we can just use vertical angles and change it a little bit. Okay, so we're given some parallel lines here, some parallel segments. All right, this one's a little bit different. Okay, we have parallel lines, so we can use some of the alternate interior, alternate exterior corresponding vertical angle stuff that we've had before. Okay, so if this angle right here is x, that could be alternate interior to this angle down here, which would also be x. Okay, they're on the inside of your parallel lines. There's your transversal and they're opposite. Okay, so this was alternate interior. 76 is an exterior angle. So the exterior angle is the sum of these two angles. So 76 equals x plus 32. So if you subtract 32, you get x to be, that's a 44. So x is 44. So that angle right there is 44 degrees. Okay, those are kind of like puzzles. So the next one's going to be even more of a puzzle. These are a bit tricky to draw. Okay, so on some of these, you may have to find other angles before you actually get to whatever the x is. Okay, so I'm given this triangle right here. I have one, this little one, this one, this one, but I also have some bigger triangles right here and right here that we can use. Okay, so there's lots of ways to do this, but let's see if we can find the easiest way. Okay, so X is in this corner right here. So if I follow those lines out, and this line out, and then connect them, so I've got X 40, and this is 20 and 90. So I really have a triangle that looks like this. X here, 40, and this is 90 and 20, which is 110. So I really just have that triangle. So if I take all of those and add them up, 40 plus 110 plus X equals 180. That's 150 plus X equals 180. Subtract 150, you get X equals 30. Okay. Otherwise, you may have to find these degrees in through here to get your way around it. Okay, so those are some examples of the triangle sum properties that we're going to be dealing with. I will post some IXL practice for you, and then you will also have your quiz to be working on. All right, thanks for watching. We'll see you in the next lesson.